Hey, what is mutation testing? What's reverse mutation testing? That's what we're talking all about today with our featured expert, Leonardo. If you don't know, Leonardo is a globally recognized quality engineer. He has expertise with over 18 years of experience from e-health to e-commerce, fintech to mobility. He has built and transformed QA teams across startups and enterprises in the US, Europe, and beyond. Also, he is the founder of QA Roots. Really excited to have him on the show. I caught this LinkedIn post about reverse mutation testing, and we never had anything on the show about this. So really excited to have him on. You don't want to miss it. Check it out. Hey, let's face it. Mobile app testing is broken in more ways than one. QA teams and developers are drowning in manual visual reviews, flaky emulator tests, and false positives that waste hours. Testing across real-world devices, often out of reach. And while functional tests may pass, you still end up shipping misaligned UIs that break trust with your users. And that's where AppPercy by BrowserStack steps in. AppPercy is a purpose-built visual testing solution for mobile apps designed to fix the pain points that frustrate modern teams. With a single line of code, you can run visual tests on over 35,000 real devices, no simulators, capturing only meaningful UI changes thanks to AppPercy's visual AI. It handles dynamic content, layout changes, and anti-aliasing noise so your team can review confidently and move fast. Plus, it works seamlessly with your CI/CD, Git, and testing frameworks, whether you're on Espresso, XUI Test, or Appium. For teams aiming to ship aesthetic, stable mobile apps faster, AppPercy delivers where others can't. It cuts review time, scales effortlessly, so you can release your mobile apps with confidence. Visual testing isn't optional. It's the experience. And AppPercy makes sure you nail it every time. And even better, AppPercy's base plan is absolutely free to use. So try it for yourself and enhance your end user experience drastically with AI-powered visual testing. And you can check it out using that special link down below. Hey, Leonardo, welcome to the Guild.
Thank you very much. No issue at all. I'm very honored to be in the Guild. So happy to be here. Thank you for hosting me.
Great to have you. I guess before we get into it, I always am curious to know, how did you get into testing?
It's a very good question, actually. Because back in my young days at IBM, I was a software developer at IBM. What happened, long story short, I think it was around 2009. Performance and scalability testing was, the new hot topic back in the days. So IBM was building up a team of, people that would do this automation, with basically consisted in testing systems where you needed to create a lot of agents. Back in the days, there were not many tools. So the idea was to build up a team of experts that would start doing performance and scalability testing. And the idea was to pick people from developers, because, those guys have probably a little bit of know-how about, building scripts and programming and so on and so forth. So there was a possibility of this pilot, and I decided to join it because I thought, it was a very cool idea to start doing something that was a little bit edgy on the frontier. And that was basically the beginning of my long-term adventure and relationship with, let's say, in testing.
Love it. So I started off as a performance testing as well. When did you start getting more into like higher level QA topics, and why? I guess you started a company that actually helps people with this as well. Why pivot that way as well?
Well, there was, let's say, a chain of elements. So once I moved into performance testing, that really opens a new world for me. My perspective was more into the building things as a developer, but then that really opens an amazing world about quality and quality engineering. And, the more I was working in that, the more I thought, there is so much room to help companies and to, make sure that the products, the services that we all love as customers, as clients, they get delivered on the proper standard. So throughout my journey, step by step, I moved from, starting from an individual contributor in a team and helping with the performance testing. Then slowly, I started getting roles where I was, the the head of QA or the QA lead of the person that, would work on the quality engineering, on the strategy. So most of the times I was collaborating with, head of engineering, CTOs. And I really like that because, beside the test automation, which is clearly an important part of the process, there is a lot of strategy and a lot of consideration to be done in quality engineering. And I really like also to try and keep my standpoint as the final client. So the final goal is eventually delivering quality and delivering business value. So throughout different roles and different companies, startups, and in other countries, I ended up, having more and more responsibilities until I thought, probably for me, it's the time to do this as my main mission, my main job, to help companies, deliver great quality. And that's what I'm doing now. And I'm very happy because it's very, motivating, rewarding, and helping companies deliver great products. I think it's great.
Love it. Love it. So, I guess the answer probably depends, but I don't know. You work all over the world. You work with all kinds of different companies. Is there any commonalities you see people struggling with testing, or is it just different depending on the vertical they're in or the country they're in?
I would say both answers are correct. So there is a common basis into doing testing. One thing that I see in a lot of projects and companies, they all try to follow the testing pyramid, doing a lot of unit tests, a little bit of integration, and as you go on the top, just a few end-to-end and, exploratory testing. So there are some generic guidelines that I more or less I can see almost in all the projects. But that's, I would say, the boundary in what is common. Then it's quite interesting that every single company does quality engineering in a completely different way. Their company, they really make an effort to deliver a great job. They create book of standard. They try to, to make their own way to deliver a great application. And they invest a lot into creating center of excellences, or, if you need to build an app, don't start from scratch, but rather download something a little bit, I would say, battery included. So, contains a lot of things that are done under the quality of the company. And then on the other side of the spectrum, you got also companies where there is basically nothing. It's just, the quality relies on the ability of developers and knowledge on developers. But, in these companies, that's where the magic happens and the fun. Try and build something that help deliver great quality. So it really varies depending on the company, but probably the testing pyramid is something that everybody more or less agrees on.
Awesome. All right. So as I mentioned, the meat of the show, I want to cover on reverse mutation testing. I saw this on LinkedIn on my feed, and I covered it in my news show. And I think it was one of the top clicked on news items. So I guess before we get into reverse mutation testing, it may be a term that people aren't familiar with, even mutation testing. So let's define what is mutation testing, and then we'll dive into what is reverse mutation testing.
Yeah, that's the right way. Let's start with the basics. So mutation testing is, for me, the first time I heard that, that's a great idea. So let's say, let's simplify with an example. So you have your code, and you have some, let's say, unit test, and which is covering the code that you're building. The main problem is that, or the challenge, I would say, is that how do we make sure that those unit tests are really effective? A lot of times people talk about coverage as a good metric to evaluate unit testing, but covering all the code is definitely a good starting point, but is that really enough? My personal opinion is no, because you could write just, as a matter of proving that is not enough, dumb test cases that just, asserting that true equals true, or asserting the obvious. So test coverage, covering all your code through unit tests, is a great idea, but it's not enough. So there is a need for me to understand, are those test cases built in a way that if there is a bug due to some code modifications, they will be able to catch the bugs? So the need is measuring and verifying the quality of those test cases. Are they valid? They really test what is important, that whatever that fails could break things and could fail deliver business value, so they could put the entire application under risk. So the mutation test comes in a very cool idea. So the idea would be, what if we have a programmatic, let's say automated way to modify our target test code? Imagine there is a tool that takes in input the code that we're testing, that we're producing, our application code, and modifies it, mutates it, if we want to use, the right terminology. What does that mean? It basically means modifying, for instance, the condition in a if-then flow. So if the then flow is executed with a major sign, you just flip it, and then you create a modified, a mutated version of these code, and then you execute all your test cases against this mutated version of your code. So why would you do something that's, the first glance you may say a little bit, that's why would I do something like that? Well, the idea is very smart, actually. If you run a test case against a modified version of your code, what would be the expectation? The expectation would be that your test is failing, because by modifying the code and by having the test case still testing the original version, you would expect this mutation make the test case fail. Now, this is something that I would say applies in general. That we could always find cases where this doesn't apply, but in general, mutating the code and running the unit tests against this code should make the test fail. So the mutation testing tools, all they do is they take your code, they apply some mutations, and mutating the code could be done in so many different ways. So also the challenge is finding the right way to mutate the code. And this is also a computational challenge, because if you imagine there could be billion of ways of mutating the code, you want to pick the right ones, because at the end of the day, this mutation testing is something that you normally would add on top of your testing pipeline. And this is something that must have a time budget. If mutation testing would take 20 more hours, it's not worth it, because nobody can wait extra 20 hours to get test results. But imagine this can be done in 5 minutes. And at the end of this automated activity, you have a report that would tell you, hey, hold on, because there are a couple of test cases that are not failing against this mutated code. So all you have to do is say, that sounds a little bit weird. So you just go and analyze those test cases manually, and you try and understand why they didn't fail. Now, there are two options. The option A is, in general, we can say there is a reason why they're not failing, and then life is good. Then you have validated your test cases to be good. But the worst case scenario is, you may have found a test case that it's not doing a right job. So basically, it's asserting something that it's meaningless. There could be an error. There could be something wrong in a way that if you mutate the code, your test case is still passing. And honestly, Joe, this is the worst situation ever, because we all rely on our test cases. We all assume that whoever wrote those test cases, and they could have been written many, many years ago, they were reviewed, they're correct, and life is good. And what is even worse, technical debt is already big normally in companies. So do we really have the time to go and review the test cases? And do we really want to review test cases which are passing? And this goes a little bit into, psychology. If I see green stuff on my screen, happy days, I feel like popping the champagne and celebrating. So the little thing that says, hey, are you sure those test cases are right? Maybe they're passing, but they're not doing the right thing. I may say, well, it would be great to validate that, but it's effort, right? But if I had a tool that would do that automatically and would point out to me a couple of test cases of maybe hundreds that could be suspicious, happy days. It's well spent time, because if you find the wrong test cases, you fix them, then you have increased the quality of your test automation, and you sleep much better in the night knowing that your test cases are really effective. They're delivering quality.
So there's a few things there. I guess everyone is always like, oh, we need a green build. We need a green build. We need a, but you're right. If it's always green, and like, how do you know it's really passing? I don't know if that makes sense. Like, it's green, but is it really green? Is that the problem? And because So I guess that's the first thing. You want to build trust in your tests. So when they fail, people pay attention. But you can't really trust them if you actually never saw them fail, I guess, the main issue. Okay.
This is exactly, this is one of my actually mantra, that is, do not ever trust a test case that you never seen failing at some point in the past, because it's too good. You make a very good point. We want green pipelines. We want everything working fine. But at the end of the day, those pipelines, those test automation, they are our guardians. They make sure that if there are problems, they find them and they fail. So in an ideal world, a pipeline fails upon problems. In reality, you can have cases in which a pipeline fails because the test case is not maintained, and that can affect the reliability and the fact that the teams are relying on those test cases. Because if they start failing, not over a problem, but over maintenance issue, then over time, teams start to, that's rare, but, it's not really reliable. They don't even go and look if there is a real problem. So they become useless. And this is something that maintenance help to prevent this situation. On the other end, and this is actually even very such a corner case, that if it's always green, but we also want to rely that green means green. Green means the test cases are passed. And we normally don't go and check if that something showing green is really green. And that's actually the catch. And by not doing that, which I think, it's the human nature, if the testing is telling us everything is good, happy days, let's just move on. But companies lose millions by relying on test cases that are not doing the right job. And mutation testing and reverse mutation testing are, relatively quick wins that can help diagnosticate, do a checkup on your test cases, find the wrong ones and fix them. And, it's much better if we find problems rather than the clients find problems due to leaky test cases. Let's call them like that.
Yeah, and it's pretty dangerous because you're giving someone a false sense of security if you can't honestly say, yes, it's green, but is it really doing what we think it's doing? It sounds like.
Yeah.
All right. So is this a one and done activity? Like, would you just write a suite of mutation tests and you run it once and you say, okay, I've seen it fail, so don't need to worry about that again? Or is this something you run in the pipeline ever so often? Like, how does it work?
Mm-hmm. So it's a very good question. So in reality, I would say that my approach, would be, it's great to integrate the mutation testing in a pipeline, but maybe it's a little bit over-engineered unless you run mutation testing only on new test cases. Because once you validated your old test cases to fail upon mutations, and therefore that is telling you they're working fine, unless you modify those test cases, and then again, you should ask yourself, are the new versions of those test cases working? This is something that you can delegate to new test cases. So it's great to have mutation testing in a pipeline, given that you tune the mutation testing so that it doesn't take too long. So mutate the test cases in the right way. There are tools that do mutation testing offering you the right way. And also make sure they take care to run mutation testing only on the new test cases, because once you validated the old one, as long as you don't touch them anymore, you can rely on them. So but I would say, that could be the to-be ideal situation. If a company starts also to say, hey, let's from time to time run mutation testing, even out of the pipeline, just to verify our test cases, sort of a manual or semi-automated process, I would say it's a great starting point, because if you validate your test cases from time to time and they deliver quality, they're testing the right thing, even if it's not in the pipeline, it's better than not doing that at all, I would say.
100%. So what's reverse mutation testing? Are these terms interchangeable?
Mm-hmm. So basically reverse mutation testing, it's something that it's a sort of an evolutionary, I would say it's a complementary technique to mutation testing. You can apply both of them. The idea that I had comes again from this mantra: do not ever trust a test case that you never seen failing in the past. So I think most of QA people, when you're in a stage that you're writing automation unit, but it could be any type of testing. As you're designing, you're implementing those test cases, you want to make sure that they're working fine. So you run them and they pass. So life is good. But how do you really know that they're working fine? The easiest way possible that I may think of is just programmatically make them fail. So a very simple example, you're testing that a module that is summing two numbers, if it takes 2 and 5 as an input, you're writing a very simple test case that the output should be 7. And this test case should pass as long as the code is really working. Now, to be 100% sure that this test case is working, what I can do is very simple. Let me mutate the output from 7 to 3, or say anything that would be wrong. And now if I run a test case that is checking that 2 plus 5 equals 3, I'm expecting the test to fail. If this happens, happy days. It's probably showing me that, the test case is well designed. The problem is if the test case doesn't fail, because I will say, hey, hold on, this test case keeps on passing even if I manipulate it temporarily by breaking it. And why is it passing? Now, obviously, on a very simple example like this one, it's not going to happen. But there are complicated test cases where you're manipulating objects, you're checking API responses, where the chances of writing a test case that it looks like it's working, but actually as a mistake at some point, it's quite consistent. And a great way is just modify the test, break it, run it, and expect the test to fail. But, this is an activity that it's relatively fast, but now scale it up to all your test cases. It's great when it becomes, part of your methodology as writing test cases. But again, what happens if you inherit test cases that were built in the past by some other people? How do you trust them? Therefore, I thought I can put all those pieces together. And I thought, hey, why if instead of mutating the target code that we're testing, and this is the mutation testing, why don't we mutate the test case, exactly automating what I would do as a tester manually? So I'm breaking my test case in a purpose way, so really knowing what I'm doing. But instead of doing myself, I let this reverse mutation testing tool doing that. And again, when I run my test automation, the mutated version against the not mutated code, I would expect the test case to fail, because I broke the test case by mutating them, and I'm expecting them to fail. So having a tool that does all of these automatically, it comes to you with a report, finding the little nasty test cases that are still passing upon the mutation, help you identify problematic test cases. And we end up in the same scenario as with the classic mutation testing. There may be reasons why they don't fail, and then life is good, happy days. There's no, action item to do, but you may identify test cases that, those test cases are, by analyzing them, you realize there was an error. You fix the error, you run again your reverse mutation testing, and this time they fail upon the mutation, and then you know that all your test cases are reliable. Now, having a tool that delivers that in minutes, and plus your extra effort just to modify, imagine hundreds of test cases, a couple of them are, not failing on the mutation of the testing. You fix them, and now you run the reverse mutation again. Now they're all passing, and then you know that your test cases are reliable. So that's basically the idea of reverse mutation test. Just flipping the angle. Don't mutate the target code. Do mutate the test cases.
All right, so this might be a real dumb question. Is it always the test case that's broken, or does it actually find real issues with the code? Does that make sense? This is just an activity to test your test code, not actually to test the code that you're testing. I don't know.
It's a very good question, actually. The thing is that when you do reverse mutation testing, or also mutation testing, the ideal state is that you're starting in a situation where everything is working, so your test cases are passing. So let's go into the reverse mutation testing. If you start in a situation that your test cases are passing, mutating them, they should not pass. So ideally, it means your code is correct. The scenario of those test cases instead failing because the new version of the code changed and this broke the test cases. This could always happen, but I think there are two orthogonal things. Here, I would say the focus is more to validate the quality of your test cases, in the meaning of catching in an automated way faulty test cases, because a faulty test case delivers nothing. And of course, by running them, you can always fall in the situation that they identify a real problem, and happy days, because at the end of the day, this is what test cases should do. But I see them as two orthogonal things.
Gotcha. So how's this different than like TDD? But you're using TDD, but BDD, I used to do TDD with the BDD. Before I implemented each, given when, I make sure to fail before I implemented the next statement. Is this the same or is that different?
TDD is, as you say, test-driven development is a methodology where, start writing a test case before the code implementation. So the test fails, and then all you have to do is deliver the minimum code that make that test case pass. So this is TDD. Reverse mutation testing is something that you can put on top of TDD in the meaning of, okay, now I've written my test case through the TDD methodology. It's failing. Now I wrote a code that make the test case pass, but am I sure that the test case that I wrote, since I wrote the test case manually, am I sure that this test case is really correct and there is no problem? Hey, let me apply, the reverse mutation testing. Let me break the test case and make sure that upon breaking the test case, it will not pass. When this happens, I know that my test is likely correct. That doesn't happen. I may have written accidentally a test case that always passes, so delivers no value. So the short answer is that reverse mutation testing can be done on top of TDD, and they're complementary and both deliver value. TDD as a methodology and reverse mutation testing as a way to validate your TDD generated test cases, I would say.
All right. So you mentioned tooling a few times, and I forgot to follow up. Is there a tool for this? What is the tool for this? I thought this would be more of a manual, just you fat fingering things to try to make them fail. Like, what's the tool you use for this?
So I clearly did a little bit of search about reverse mutation testing and tooling, and I found nothing. Basically, the best practice of breaking your test cases, in the process of developing that. So I decided to write myself what I would call a POC, or proof of concept, of a reverse mutation testing tool, just to create something that can be easily used. But obviously, the idea would be let's create something which is an MVP, or really like showing the concept. And then I created one. Is you can find on my GitHub. It's freely downloadable. You can check it out. Actually, I had already a pull request by a nice person, I think from India, that already found out some improvements, and I'm very happy because eventually that's the goal of having GitHub projects. Make them available to the community, and the dream is having the community contribute to them. So I created it. It's quite basic because basically what it does in this example, it takes existing test cases, it creates a version, it writes it into the file system, and the mutated version. So it creates this mutated version, and he run the mutated test cases against some toy code that I've created, and he creates a report identifying the test cases that don't fail over the mutation, so the suspicious ones. Of course, real mutation testing tools, they don't create physical copies of the code in this case, but they would rather use everything in line in memory. So there is a gap to implement a much better version of reverse mutation testing, where the mutations of the test cases can be created at runtime in memory and run them. But the idea is that let's build some foundation, and then if the community sees some interest, we can build a better version and more optimized, and start piloting in some projects, I would say.
Nice. So I know you're a big proponent of lean QA and shift left practices. Does this slow things down? Like, how do you know what you should everything be mutated testing, used for mutated testing, reverse mutation testing? Like, and how much data do you need to validate whether or not it actually is passing then at that point?
Yeah, it's a very good question, because at the end of the day, is it worth doing mutation testing and reverse mutation testing? My answer is yes, as long as you have a time budget, as long as this doesn't affect the pipeline execution. If I need 20 hours to mutate my code or my test cases, it's clearly not worth it. But again, if we create a tool which is optimized and very fast into mutating the test cases, and we do a proper mutation, you can mutate the test cases in different ways. You can change the assertion, you can change the result, the condition, and so on and so forth. So by implementing, and this clearly has a room to discover how this can be done, but by finding the right way of mutating test cases and implementing a tool which is optimized, we can make sure that the time budget for running reverse mutation testing is under control. So personally, if somebody tells me, hey, would you pay 5 more minutes in your pipeline, but the return on investment is you identify potentially broken test cases, the next time you fix them and life is good, I would say definitely. Because if this prevents the situation of a green pipeline, life is good, but the test is broken, this prevents the possibility of a bug to escape and to go to production and eventually being found by clients. And, we all know that through bugs, companies lose reputation. The damage can, potentially make the company lose millions of dollars, of euros. So my answer, if we can time budget, time limit the execution of mutation testing and reverse mutation testing, I see a lot of return on investment.
All right. I'm surprised you went this far without talking about AI, but obviously everyone is talking about AI. Since you've been around for a bit, has AI really changed QA and testing? And where do you see the role of testers going in the future? Because a lot of people are saying it's going to diminish, or some are saying it's going to grow. I hear all these companies, founders of AI, saying we're all doomed. Where do you stand?
So I'd say a couple of points. So I think embracing AI it's great, as long as you don't deliver everything to AI, but ask AI to you can divide some tasks and ask AI to implement some automation for you. As long as you understand it, you review it, you own it, and you even ask AI to explain how it implement a certain solution, when you can clearly see that's something I would not be able to do that, but definitely embrace it, because it increases your productivity. I actually think, a lot of companies are probably thinking that everything can be tested through AI, but at the end of the day, I think you still need somebody to validate it. So I see a shift in the role. You can delegate to AI a lot of work, but you have to be in control that it doesn't hallucinate and it delivers a great job. The other side of the medal is I see still a challenge on how to test AI-based software, for instance, how to test non-deterministic systems. How am I testing like a chatbot? Unit testing, like when I ask a question, the answer should match my expected one. Clearly, it doesn't work when we move from determinism into the world of semantics, where a question can be answered in many different ways with the same semantics. So that's actually where I still see a challenge of human beings needing to find a way to automate non-deterministic system. So I still think that real humans can and must deliver a lot of work in the age of AI. It's just, as every big revolution, there is just a shift of the work, but then we definitely need to continue working on that. So that's my take.
All right, I forgot about one last question. A little plug for your company, QA Roots. What do you all do if someone's listening? Who's a good fit, maybe, that they can contact you to maybe get some assistance from you?
Yeah, absolutely. So I created QA Roots with, the metaphor of establishing quality assurance and engineering as the roots, the foundation of your company to deliver an amazing product, the three. So the philosophy behind the company is really to help companies deliver great quality through, best practices and quality engineering. So I'm super happy to discuss with any company in the need to, create quality engineering or even to fine tune their existing practices. So I'm absolutely happy to support them through my knowledge, and feel free to reach out to me. And, sometimes quick fixes, quick wins can deliver incredible quality. It doesn't need to be necessarily things that last for a long time, but even just starting in a conversation, I'm happy to have companies deliver even better products.
Absolutely. All right, Leonardo, before we go, is there one piece of actionable advice you can give to someone to help them with their automation testing efforts? And what's the best way to find or contact you?
So definitely, I think my suggestion for testers is, those were the days where, you can do black box testing and remain at the surface. Try to shift left also in the testing. Try, to be adventurous, understand the code that you're testing, even if you end up doing just end-to-end tests. Talk with the developers, establish a good relationship with them, analyze also the way the unit tests are written, consider normally they're done by developers. Be involved into, the code reviews of pull requests, merge requests, and analyze the way they're testing. Provide your suggestions. Don't be afraid of the code. You can even create a little project on your server where you start writing some code and understand also the challenges from the development standpoint. But really be curious and get as close as possible to the code. This is probably the best way to become an excellent tester. To answer your other question, the best way probably to reach out to me is either through LinkedIn. I'm very happy when people contact me, and I try to reply to whoever writes to me. Or you can write to info@qa-roots.com, and clearly I'm absolutely happy to reply. And I monitor the email every day, so those are the best ways to reach out to me.
Thanks again for your automation awesomeness. The links to everything of value we covered in this episode, head on over to testguild.com/A548. And if the show has helped you in any way, why not rate it and review it in iTunes? Reviews really help in the rankings of the show, and I read each and every one of them. So that's it for this episode of the Test Guild Automation Podcast. I'm Joe, and my mission is to help you succeed with creating end-to-end, full-stack automation awesomeness. As always, test everything and keep the good. Cheers. Hey, thank you for tuning in. It's incredible to connect with close to 400,000 followers across all our platforms and over 40,000 email subscribers who are at the forefront of automation, testing, and DevOps. If you haven't yet, join our vibrant community at testguild.com, where you become part of our elite circle driving innovation in software testing and automation. And if you're a tool provider or have a service looking to empower our guild with solutions that elevate skills and tackle real-world challenges, we're excited to collaborate. Visit testguild.info to explore how we can create transformative experiences together. Let's push the boundaries of what we can achieve.
The Test Guild Automation Testing Podcast. With lutes and lyres, the bards began their song. A tune of knowledge, a melody of code. Through the air it spread like wildfire through the land, guiding testers, showing the secrets to behold.